Hello, this is the AI in the Enterprise Virtual User Group. My name is Eyal, and this month we have Hobbert Evergreen, and he is going to discuss robotics and AI and games. And we also have Dave Snowdon. I hope I'm saying the name correctly. Is it Snowdon or Snowdon? Snowdon?
Uh, Snowdon is fine.
Okay. And he's also a robotics expert. And we are hoping to be joined by Mani Sarkar soon. And we are going to have it's not a regular presentation with slides. It will be more of a webcast type. We trust our experts to tell us about robotics, and I'll try to help a little bit navigate the conversation. Hopefully, Mani will join and help as well. But let's get started. So my name is Eyal. I have been running this group for a while. I um, I work as a data scientist, and I'm quite passionate about AI and machine learning. I also do a lot of genetic algorithm stuff more as a hobby. I haven't done too much robotics other than simulated robotics, like some reinforcement learning with some of the open AI gym. But that's about the extent of my experience. And I was helping the skill team in the first robotics one time. So can you, Robert, introduce yourself, please?
Okay. Well, I am. My name is Robert. You can call me Bob. Uh, and I am. I am. My first degree was in psychology, so I started studying psychology. As I work. I am expecting to be a psychologist, and for some reason, in the middle of my career, I just have a big change and I started learning about robotics and electronics and programming. And this turning point was the greatest. I was no expecting. I was not planning this, and that's the reason I am here right now. I bring some different approach of technology just because I look to technology as a psychologist point of view, but I am also a researcher. I am already doing my master's degree in automation engineering. I am yes, I'm program. I know the whole stack of technology. I am not just a psychologist, but I am always looking to the problem and always looking to AI like a psychologist. This is cannot be changed. I always look into the human part. I am always looking to that kind of approach, like a psychologist of robots, like something like that. Join people with robots and how to interact with them, and that's my major approach and my major difference, and that's it.
So Dave, can you tell us a little bit about yourself?
Sure, yeah. I'm Dave. I'm based in London. I'm a software engineer and sort of an amateur. I've got an amateur interest in machine learning. I don't claim to be a data scientist or anything like that. I've been interested in robots for a while, but also I guess my background originally started out in sort of human interaction. So originally my research was around sort of virtual reality and how do people interact in virtual spaces. And I've been for a fair number of years now interested in robotics and in particular social robotics. So that means I'm less interested in the sort of inverse kinematics and the how you make robots move, but in how they interact with people. And that's quite an interesting problem because obviously you got the motion, but also what does it mean? How do people react to that motion? And how does the robot move and interact in a way that makes sense to the people around it? So that obviously involves a lot of hard problems, such understanding natural language, understanding vision, so processing the world around you, making sense of that, making a sensible response. And there's many things that are interesting here. Even the form of the robot interacts, how people who interact with it. So you maybe see this guy behind me here, there's a now robot. Because it has a human shape, people assume it's smart, and it's not actually terribly smart. It has an atom processor. It can do a bit of speech recognition. It can move around, but it's not going to take over the world. But because of its shape, people automatically assume that it can do certain things. It can understand you, even when it's powered off. Apparently, so I've had people talking to it when it's not on. So there's a whole world of interesting possibilities around that, and it's one of the things I find fascinating.
So, Mani, can you give us a quick introduction as well about yourself?
Sure. Yes. So I'm Mani, just like Dave. I'm based in London as well. I like to introduce myself. Initially, I'm primarily a software engineer, but I also do data and machine learning, both as hobby and learning the subject, but also applying it in my work. So at work, I hand make statistical models or do data analysis, but as hobby, I'm actually building machine learning models. And it's mainly my interests have actually gone in the areas of finance, learning price actions, reading the charts, but like using models to read the charts, using statistical models to understand price actions and technical analysis, and automating that. So I'm at an extremely early stages of that. I mean, sure, the finance industry is very advanced, and there's a lot of proprietary information there that I haven't learned yet. So that's been my more or less my areas of interest. And yeah, I have had actually endeavors with different people who are already on the chat today. Dave and I used to be at the same study group a number of years ago. Suash and Eyal, if you remember, we've been doing on and off Java and AI stuff. And I actually have a Git repository that I can quickly share where lots of different people's works there. You'll be surprised how each one of you have influenced my career and my hobby and the open source and meetup like or online endeavors like things. So we've been doing different things, and you can see in the background here I've got some Oracle community stuff going on as well. So yeah, that's me. I just to say robotics hasn't really been, I have been interested in it, but it's not somewhere where I've explored. But the aspects of robotics that I've been interested in, actually Dave and Hobbert both kind of covered. So I'm more interested in the intelligence transfer, memory, intelligence layering, because I mean lots of our models are very uni-layered or mono models. You can't, I mean, it's only now that they're having models where it can have multiple skills or more than one trait. So I'm interested in that. I'm interested in swarm intelligence because the collective intelligence, when you connect multiple models together, is different than individual intelligence. So, but not into the mechanics of, as Dave was saying, into how the robot moves and how it make it move, but more into, if the furthest I've gone is creating chatbots that talk to each other. I'll share the project here. Maybe it'll be of interest because it does some fun stuff, and maybe you can, one of you or all of you can contribute to the project and take it to the next level. But that's I'll stop there. That's my introduction. So I've just shared the link to the chatbots conversation. It's a it's a it's a multi-language based project, so you can create your own bots and connect it to the environment, and run them all together and then make them talk to each other. So just now it's using very simple vanilla models, but the idea is to connect it with smarter models and see if they talk to each other and what do they talk to each other. There's a lot of work needed there to take it to the next level. So I'm actually collaborating with Hugo on this project, and we have different ideas. Just now it's using REST API to talk to each other. The next level is to use WebSockets, and at the moment there's only models like ELIZA and I think there's a transformer model or Roberta, if somebody's familiar with the BERT models. That's talking to ELIZA, and ELIZA is talking to ELIZA as well. but at some point, all of the 4 are talking to each other. It's usually gibberish. But the idea is if you connect some smart models and make them talk to each other, because the system already knows how to initiate a conversation and then get it going, and it then endlessly goes on, but it's all endlessly bad conversations.
I
So
have a
if you
question.
imagine if you had at least one smart model or 2 of them, there would be at least one sensible conversation in the thing. So maybe
That conversation is over network.
yeah. This is
Yeah.
it's a Docker
We can
container. You run it.
we can make a Brazilian chatter talk to a England chatter.
No, it's not humans talking. Over here, there's a program running. There are multiple programs running, and they connect on the network on your machine, and then they talk to each other inside the Docker container.
They exchange strings in English, right? It's
Yeah,
all in
exchange strings are in
Okay,
English.
yes, that's the question. The exchange is in English, but the conversation can be
It's very open. You can if you use a model that doesn't speak English, you can still connect it to the system, and you can still have the conversation. Well, that's the whole idea, right? If there were smart models, then would they be able to understand other languages? And then would they switch from their language to another language? So that's the experiment we can do. You can take this to various limits.
But just to confirm, the bots can talk to each other through the network. Through the network, we can start a bot here, and you start a bot there, and they are talking to over the net.
You could configure this to do that.
Okay.
This is a very simple Docker container where it uses REST API to talk to each other. So you could do that, because all it needs to know is the server address, right? It doesn't really matter whether it's running on your machine. So the setup is there to do that. You can run your container, the server on your machine, and you can modify the other parts to run anywhere, and they connect and they discover the network address and they connect to your server. And then it could be anything. It could be a human being connecting, because that's one of the experiments we are doing. Is the reason we wanted WebSockets is now we can connect to the server through the browser instead of having to run a REST API application that runs on your computer, right? So have a look at it. I've shared the link. Any questions you have, the answer should be in that repo, because once you run it and play with it, you'll know what to do, because all the questions you're saying, all those answers are there, because it's only a matter of configuring it. You can replace the models with whatever you want. It can be an end user or it can be an app. You can replace the central server running on your machine and have remote apps running connecting to it. All of this is happening inside a Docker container, so it's system architecture agnostic. And your apps that connect to the server, they can be anything. They can run from a mobile phone. It's all agnostic. We're trying to make the architecture agnostic. And then you can replace those models, which are currently single programs, with anything. You can replace it with a robot, like maybe the Now robot. If you can get it on the network, you can make it talk. If you can make it talk to the server, it can do that as well. So you can maybe have 2 Now robots talk to each other. We haven't gone any further than text communication. So video and speech synthesis, we don't know that yet, if it can happen. But the infrastructure is there. At the moment, we are exchanging text strings. You probably have got to modify that to make it exchange a bit more heavy-duty media, right? Like speech synthesis would be like other types of data objects being transferred. So that's where it is. Have a play with it. The infrastructure is there to take it to the next level and replace the bits and pieces with anything you want.
So,
okay, have you come across Replica? It's by chance.
Replica.
Yeah.
No. What is it?
It's a chatbot. It's a commercial one, but it's surprisingly good. It's probably one of the better chatbots I've found so far.
Mm-hmm.
And I think under the hood it's based on they claim it's based on it's based on some sort of deep model. Some people say it's been saying it's a GPT-3. I'm not entirely sure it actually is. But the interesting thing they have is it over time it sort of learns how to talk to you. So it kind of learns your behavior patterns, and it's you have to suspend disbelief a certain amount. You're not really going to be fooled into thinking it's a human, but it is actually pretty good.
Yeah. See, that's exactly where we wanted. That's where I came up with the idea where I came up with this is because all the chatbots that we see, it's a bad thing to generalize. They don't have memory. They forget, right? After you shut down the program and you restart, which exactly what this does as well. So we could always take this to the next level, this simple program to next level, and that replica you mentioned, whatever model they're using. I mean, I haven't connected a transformer model to this yet, and I haven't connected GPT-3, and I don't know how I will do that because of all the different hoops we got to jump through to connect to GPT-3 online. Unless you take a very miniature version of GPT-3, like which is small enough to run somewhere and then connect. But once we do that, and when the next thing is to build memory, right, to remember that conversation,
Yeah, I
that
mean,
is not there. Yeah.
I mean, that's the interesting thing. Replica does have some memory, so it's kind of a bit weird. You know, if you say, "Hey, you know, I have a dog," it does remember that, and you know, at some point you can say, "Okay, well, you know, maybe in a few sessions since, you know, what do you know about me?" And you go, "Oh yeah, you've got a dog, or you like films," but it's not very good at using that in conversations, and so it has this kind of weird disconnect in that it has this context of about, you know, a few sentences ago where it's very good at reusing that, and then occasionally, if you ask explicitly, can remember things from long ago, and then there's sort of a big gap in between there between explicit things it's actually put in basically a key value store, and
Yeah,
then
I think that's
recent
probably
context.
yeah. It's bad to assume what they're doing in technology wise, but you could do
Yes.
a very vanilla version of username and building a model on the fly of that conversation, like a layer on top of its own layer. But then that's not going to be very good because so many conversations can go in so many directions, and it only be as good as that system is. And then maybe it's sending queries to those different models at different times and probably gets the answer right sometimes doesn't get the answer right. So
Yeah, it's quite interesting. There's that. Yeah, but people have been getting very attached to replicas because you can customize them and give it an avatar, and there's
okay.
a whole subreddit about it, and it's quite fascinating because how attached people get to their particular chatbot.
Yeah, can you make it connect to something like, if we have whatever example I have here, if you run it, I mean, there's a WebSocket branch, there's a Git branch which has a WebSocket implementation of it. I haven't done that, but it'll be interesting to see if we can, through API calls, make it connect to this central system, and then make other transformer-like models also come on there, and maybe they will be inputs to replica's outputs. Like, replica will be the smart
Yeah,
one answering, whereas these
yeah, they
people will be
don't
giving in answers.
they don't support that out of the box, but they have a web UI, and one of the things I've been meaning to do for quite a while is to use something like Selenium to try and
Yes,
write something that automatically sort of injects and grabs the output from replica and injects
that's
input
a
into
smart
it.
one. Yeah.
Yeah,
Yeah.
so that's been on my list of things that I want to try.
Yeah, say if you want to experiment with this infrastructure that we created, there's a WebSocket piece of code which we haven't merged yet, but it works. And even without it, you can still use the API calls. You'll have to do the scraping, as you said, from Selenium, paste it here, take the code from here and paste it back into Replica, and then back and forth. That interface might need building, but this interface is ready here. Because Eliza, if you know, takes your sentences and builds its own sentences based on what you're saying in a round robin repeated fashion. So that makes it looks interesting. And Roberta has a Q&A model built in it. So you give it a question, you say something, put a question mark after it. It'll try to answer it with something sensible, sometimes something gibberish. So you can see some conversation going on. But if you have a smart bot like this, and then you connect it, at least it'll try to take something or input back some sensible thing into the conversation. Yeah. At some point, you start seeing messages like, "Oh, what are you talking about? Oh, is that the same thing I was talking about, right? No, I'm talking to you." Yeah. It's like you just go on repeating the same thing again and again. I've
So
shared the links in the chat. I don't know if either of you have got it, but you'll see there's a video there as well to see what
Yeah, I
the
saw the
outputs
links.
look like.
I'm going to use this as a segue to ask Hobbert about the connection between psychology and robotics. Eliza used to actually originally it was used to let people open up and talk to. They found that people were willing maybe to share more with this program than they would open up to an actual therapist. So these things have actually started with some kind of a connection to psychology. But how do you take it further? How does psychology connect to robotics in general?
Yes, it's a good starting point. Well, when I first know about the Liza, and I know that this is based on a psychologist and in a psychology approach, uh, I try to understand because I know the theory and I know that the programmers don't know the theory of based the psychology theory based, and I was thinking, wow, how could be a chatbot based on psychology? And yes, this was the starting point. And just Manny said, well, the way the Eliza interacts, sometimes it's much more you talking something, I will answer something, and this question and answer, and the simplistic way engages. And this is amazing because the Eliza didn't know exactly what she is talking about, but engaged the human, sometimes being engaged on that conversation. And other times, yes, the conversation go into an infinite loop, and that's it. Well, and so for that reason, I started when I first started looking at the psychology and the programming and the artificial intelligence. For me, when what I am expecting as a psychologist is something near the intelligence what I have studied. The child, the child born to the adult life, all the stages, all the learning, and the or a Freudian approach, like we have something in our mind, we have some desires, a contradiction between some desires. That was my point of view when I started looking at the chatbots trying to do some kind of conversation. I was, well, is not what I am expecting to see, because the way I look to intelligence, it's a little different, and I start to trying to figure out what's going on. What's the difference of my approach and the difference between the intelligence artificial approach? And there is some uh, psychologists looking for trying to understand artificial intelligence also. So I understand that my point of view, it's much more closer to emotions, much more closer to goals, much more closer to learning in the in a much we as a psychologist, we never try to explain how humans think. We never how the neural connections between how it happens in a physical world. But when we are dealing with a chatbot, we know what is going on inside. We know what every line of code is trying to do. We know, oh, here I will capture the sentence. I will cut the spaces. I will grab the question mark, and we'll do some kind of processing. And the answer is that. Wow, this is a high detailed way to look to intelligence, and the psychologist way of looking, no, we don't explain anything at all. We just grab the big picture. Wow, seems that some people have some interests, and this came from here, and they take some decisions and do that. Well, that's my beginning. And for me, this the starting point didn't connect. I know, at that time I look at the psychologist and I think to myself, well, there is a gap here. We are not trying to connect the real world with what are we are talking about. It exists a real world, exist neurons, exist a body, and this must connect. And think the theory, the psychologist theory, must connect with the reality. There, if there is, if this connection didn't exist, we are not explaining human being. We are not understand what human being is. And this triggered just when I started looking to the code. This triggered to me, well, I need to understand this better. And psychology itself is not trying to understand at that point. It's just a high layer. Uh, and for me, it was so amazing to understand that and saw this gap and saw that something is missing. So I started to understand the hardware itself, how the computer works at the minimum details, looking at the low code, looking at the beats, looking at the hardware, the architecture itself. How can we build a microcontroller? How can a structure? How is it structured an ULA, for example? How a math? How we can compare in base? How can compare a number to each other, and at how the hardware do that? How the hardware can tell me if this is equal to that? How? And I am look at this very first beginning. I am look at the beat, at the energy point, turn it on inside the microcontroller, and how this can make how this can make a comparison to build an if else, how an if else is building. And I started understanding what can be obvious for someone is from technology, that is just a matter of computer processing some steps, and there is a clock organizing all the steps that a program can do, and these steps will pass in steps by step, doing line by line, doing count by count, and came into an output, and this output goes to the robot itself. So I need to try to understand how this connects to psychology, and how the how we can make something that makes sense to interact with each other. And at that time, I was looking to neural networks based on the brain. Well, this is interesting, and I started discovering something like um, reinforcement learning. This is based on psychologists, and lots of kind of approach. Some approach that are not being used anymore because they explode on search or for any kind of reason. And I start to, well, how could we make a machine think or act reasonably, do some reasoning to do some actions. And well, what I am looking right now is that there is some limitations that we are already known, but we are trying to overcome. And what I am looking at, for example, when we are looking to DeepMind group doing StarCraft, they are understanding things that for me was the keys to join psychologists and robotics, because for the philosophical point of view and the psychological point of view, we are not building from scratch. We are not building. We are not an empty code. Human is not an empty code. We are not born like there is nothing there. But and when neural networks starting some approaches like transfer learning, well, they are not starting from zero anymore. When this guy on the StarCraft said to me said when this guy said, well, we cannot start randomly, we need to look at some players, the amount of actions is so big, the space we have to explore is so big, we cannot start from scratch, we cannot start doing random actions, we need to start from some starting point. Our starting point is looking to players, human players playing StarCraft. Well, that is the connection. That is where we are right now. We are understanding how much the exactly point of learning that we have already passed to the artificial intelligence, and the what the artificial intelligence needs to learn, because there is a point of when our neural network have no weights trained, and there is a point there is fully overfitting. So there is a middle point. We need to start at the middle. And we are now trying to integrate that kind of solution. And that kind of solution is based on human teaching computer, players playing StarCraft, and this is the starting point. Well, I need to tell something. They tried before that. When they are trying to build a chess player or a Go player, the the main idea is we can start from zero. We can make a player that play chess play against another bot player, and this competition against the bot competing to another bot can be a starting point. We can start from zero. But when they try to play StarCraft, that is not possible because the amount of actions and the spaces are so high. So they starting doing what our moms do with us. When we are babies, we we know something. There is something we are already knowing, and but the language, we are not creating the language itself. We used to imitate something, someone talking, and we starting to look someone talking, and so we have the hardware, our body as a hardware. They have enough con- they have the enough knowledge to learn how to speak, but the language itself they don't know. That's the limit. We can know any kind of language, but we have already the ability to know a language. Well, that is the where the relative point where we can start from. So I am looking at lots of the researchers uh, doing this kind of approach. We need to start from some point. We need to give some intelligence, some initial intelligence to our robots or to our bots because they cannot completely start from scratch. This is mandatory. And this is so amazing because now we are teaching the artificial intelligence being smart, and that's it. That's the very first beginning. But we can't in my point of view, I look at the problem, I look at the intelligence as a researcher, not a psychologist, in three different points where we define that there's something must be solved. How we The second point, how will the options we have to solve this problem, and the solution itself, how we can optimize the solution itself. For example, if we are came into our house and we saw that there is some water on the floor. Well, at the beginning, this is not a problem. There is just water in the floor. This is not a problem. But we as human define, well, I will clean this. Yes, this is the point one. We created a problem to solve it. There is nothing. It's just water on the floor. But now there is a problem. Uh, the second stage. Well, how I will solve this problem? I will I will just do nothing, and the water will disappear because the weather will solve this for me, or I will make something, pick a paper or any kind of different kinds of problems. Okay, this is the second step, looking for different ways to solve the problem. And the third step, well, I decided I will use a paper to dry the water. Well, in that case, how best can be the solution, the optimization? Today, our artificial intelligence is much more based on this third stage, in the optimization. Find the best solution for a problem that we already we are already selected how we will solve the problem, and we are already selected what is the problem. So this step one and step two, we are doing for the intelligence right now. We are telling, well, you are a robot, and the problem is you are a car, and you have to drive without We have to drive on the city autonomously. Well, how we can do that? We put some sensors, and the calculations are that, and the amount of freedom you have is that, based on that constraint. And that is the point right now. We are much more on the optimization point of view, and the middle point is where there is some kind of interaction with humans. But we decided, well, I will use a neural network to solve this problem. The inputs are is that, the outputs are that. Just train, I will select the architecture of the neural networks, but the optimization I will leave to the machine do itself through loops and through any kind of approach. And what I am looking for right now, and what I am expecting, is just to extend this learning to architectures. And when we decide the problem we have to solve, to give the opportunity to artificial intelligence to learn by itself how they will solve, and the optimization will come before, after. That is the main question. And I believe, and looking at the other researchers, this is naturally became a part of the research they are doing, because the lack of, when we think trying to solve some kind of problem with no information, or when we are trying to solve some problem with some initial information, is better when we have some initial information. And it's based on, as I said, the way we learn as a baby. The way we learn, we know lots of things, but I don't know why people put in their mind that we need to start from scratch. I don't know why. And when we look at a baby, no, they don't start from scratch. When you look at an animal, well, we can see the small pets. They already, uh, as soon they are in the world, they are interacting and living and doing any kind of stuff by itself. There a lot of learning became, uh, from zero. And
It's
there is some. Yes, feel free to ask me.
I was just curious if it relates. You mentioned six-layer architecture of learning. Is that related or is it?
Yes, just because, well, I started to separate. I don't know if this uh, my approach is something like that. Well, we have a starting layer. The I will talk about six layers. We have a starting layer where is the sensor layers. We have the inputs. We Let's suppose we have a camera. We have the pixels of the camera, and we have the matrix of these pixels inside of computer when we take a picture, for example. Well, is this is the first layer. We can put, for example, a neural network to recognize that image, like a deep learning model, and find some information inside that image. Look, if some object detection, some kind of the some kind of detection, can be a detection, but I'm thinking about an image, so they detect a cat, a dog, a person, an object, and some kind of that. Well, this is the second layer, because we are not anymore dealing with the sensor. This is completely abstract. We are doing with pixels, and we are make some calculations, uh, over these pixels, and we are concluding that maybe there is some object here, some object there. Well, for us human, for the computer is just mechanical point of view. Well, when we are in the third layer, we we have detected, for example, there is a dog and there is a person, and the dog is running in the direction of the person. Well, this is the first layer, because we are making some assertions about objects. We are not dealing with sensors, we're not dealing with the detection, but we are dealing with the relation of the detections have to each other. This is the third layer. And for the fourth layer and above, it's much more psychological. What the feeling we have to deal. The fourth layer is what we feel about what the experience that I have related to this detection. Because when we are deciding something, and is important because the emotions itself is not something that we learn. We not learn have emotions, but emotions have a great part of importance when we are deciding something. We make some decisions based, well, I will through the left or the right, based on an emotion. Let's suppose you have to decide to go to the market or go to the gas station, or something like that. Well, if you are feeling hungry, I will call emotions in a broad way. If you're feeling hungry, this became from your body. This is not learned. You don't f- uh, learn how to feel hungry. This is something inside of you, but it's part of your decision, and your decision is based on that. And in the fourth layer is something like that. How we can make this very how we can make a computer have this notion that there is something inside the robot itself that lead the decision to certain points, and this decision must be something like hungry, must be something like emotions. Oh, I am feeling glad, I will swim. Or I am not feeling good today, I will stay at home. This is part of our decision, and this emotions is not learned. And i- and that is the fourth layer, have emotions to be part of our decisions. Well, in the first layer we have the sensors. We detect something, we make some relations between these objects, and now in the fourth layer we can organize our decisions, what we will do in relation of these detections, and the relation these detections have it to each other. Well, in when we think about the, f- the fifth layer, the five the five layer. Well, we need to have some kind of reasoning and some kind of wisdom or some kind of better choices. Or, well, there's something we can decide that can be done but is wrong. You It's like ethics. We can do, we are able to do, but we are not do because of there is a lot of rules emerging from this complexity, and is this ethics where it's interesting because we are doing ethics decisions all the time. We have decisions based on emotions, and we are decision based on ethics, and these different kinds of layers. And at the last layer, the sixth layer, I understand that we are talking about the awareness, how the how we can look to each other. Well, I am doing this. I am doing that. We can we can look to our life like we are not living. We can look outside of our decisions. Well, my life was in this direction. We can look to ourselves. We can be aware we are having a life where we can be aware people around us, and that is the dreaming layer, or where the a computer can think about it. Well, thinking about practical way, I am understanding that the first, second, and third already have. We have. It's possible to have read some sensors, extract some information, and make some relations between this information. Yes, this is already done. We are improving in that way. Well, feeling emotions, I understand that when we talk about it, and this is an important question because people are always asking me, well, when a robotic will be like a human, Well, my answer right now is never. Never will be. It's just like a dog will never be a human. Dog is a dog. Human is a human, and we think differently. We treat differently because the hardware is different. We are not supposed to expect a different hardware to do the same thing, uh, just because they are different. So in that case, emotions, I understand right now. I must be wrong, but right now I understand that our hardware is not able to feel emotions. It's a hardware question. It's not architecture question, and for that reason we can overcome based on the four layer. And when we think about ethics, it's much more reason, much more something where when we can think about it. But because we don't have emotions, maybe we need to pass to emotion to understand what is wrong, because emotions is pretty much linked with what we think is wrong, because can damage someone, can hurt someone, can make someone sad, can this is maybe the five layer cannot be achieved just because the four layer are not able to be achieved right now, and the sixth layer, I don't know what to talk about.
But I don't know. So are emotions really connected to ethics? I'm kind of not sure they are. I mean, it almost seems that emotions in some ways are sort of a bit like an attention mechanism, if you will.
Yes,
It's saying, hey, oh well, this thing's important. This thing's important. I should care about it, and because it's a big scary thing, or it's something new, and it's making me think like I'll prioritize this thing happening here as opposed to something happening over there. That's
yes. The idea of the addicts is being connected to emotions is not that emotions causes the addicts, but the emotions is something we have to think about. Emotions, we have to think about the feelings of people, we have to think about it's a rational decision. Yes, when we think about addicts, is a rational decision, but there is a rational decision based on, oh, I will hurt these people and I will do not do this. Ju- when we saw something, when we see someone sad, it makes feel something. It makes our our mind think in a certain way, and that's I'm talking about emotions have a big important part in on ethics, just because of that, not the emotion itself. It's not the emotion
okay.
causing the ethics.
But you know
Cool.
what? I think Dave brings a very important point. But what I'm thinking here is, I think we may also not be introducing context here, and there might be multiple context here. See, for example, age is an important factor as well, right? Like, not, let's
Yes,
put robotics and all those aside. If you talk about these six layers you're talking about, like when you're growing up, your sixth layer and your fifth layer is not developed yet, right?
yes,
But then
yes,
also look at it like this: the first and second and third layers, they need to be at least at the minimum optimal functional levels for your remaining layers to get developed, right? Because, for example, if you talk about people with disabilities, right, now when you then
yes,
apply that and model that to the three layers, I'm not an expert in this by any stretch. How will the other three layers get developed? Because sometimes you have a disability. They say that one disability in one aspect develops another aspect to various degrees, to a maximum degree, or to compensate for the disability, right? So how do you model that back into the six layers? Because maybe they'll be very good at layer 5 but really bad at layer 6, or vice versa. Very good at layer 6 but might not do very well with layer 5, right?
yes,
Because,
yes,
like, you said emotional rationality, like there are people who don't, like, and it's not disability, but I know that sometimes people forget to eat. It's a strange thing to say, but you must have heard of this, right? And it can happen to various things, right? Through forgetting because you're so busy, or the bodily function itself doesn't function well enough, or there's a mental disorder, and all those things. Now the other layer is affected. But it's strange, even though you say one layer feeds into the other layer, but I think that they interact with each other and develop each other, and it's not a one-way ticket. They are
Yes.
complicatedly interact, because sometimes once you have your maybe fifth, fourth, and third layers developed, and maybe your first, second, and third layers were not so developed, you can actually use that to further improve and correct your first, second, and third layers, right? More or less, it's not correct what I'm saying, but you can understand, right? So when you grow up and you learn, okay, if I exercise, I'm going to fix this part of my physical being because it used to be hurting or whatever, or if I do surgery, that's going to get fixed. But only you know that after you learn that, after you've developed at a certain stage, right? So i- it's complicated, isn't it? It's not,
Yes.
even though, yes, you are very rightly saying first, second interacts with the, but I think it reverses also true. And complicatedly, the sixth layer might be helping the fourth layer and vice versa, and interacting with the fourth layer and vice versa.
Yes. I, I, I this question is interesting because there is a hardware question in between them, because we are thinking about, for example, a robot, and the robot can, for example, if it's a humanoid robot, they can lost one leg, lost on one arm, and this will be part. This is important to the robot to know that they lost one arm to make
Mhm.
decisions, but specifically when we are talking, they have some disability, and the second layer, for example, or some disability on the third layer. Well, I believe that will happen. There is uh, someone pressing some keyboards.
Yeah, I
This
think
this
someone's
is
typing.
an open mic. Yes, great. Uh, and this kind of disabilities is something that your question is important, because when we are looking at human being, we are always almost 100% of the time talking about a human being, what we call normal, what we call fully developed, or fully functional. And yes, it's a problem. We can think about some computer uh, based on webcam, for example, and this webcam can be damaged for some reason, and the detection is not occurring as we are expecting, and the decision will still based on that detection, and this
Exactly.
detection will corrupt all the system. Well, this is something that we have to deal, and if there is some kind of damage or some kind of the development stage that we are not achieve, yes, will impact in the other layers, yes, because they are always all together connected. There is no way to run from that. This is a intrinsic problem of the behavior of itself. Just just like we have to deal with this. Yes,
Yeah.
it's a you're touching in a point difficult to understand, just because we are harder evolving. We are
Mm,
person. We are the the our as human being. We are changing.
mm.
Uh, the ethics it's changing. The body itself is changing along the way, and it's changing at the aging. Yes, the baby thinks completely different than an adult, and an adult, depending on the path they pass, they will not achieve some kind of development. It will not understand even getting older. But I believe that is some part of intrinsic problems of the hardware itself, intrinsic problems of the development itself. And we are always trying to look things, looking for a normal, or what things must to works, and this brings us to some relative points where we don't know exactly how to deal, and I believe it's something like that.
Yeah, so I think you touched on something very important there, which I wanted to bring up is, um, I think I mentioned this earlier as well. So for this, we still have to achieve the advancements in hardware with relation to robotics, uh, but also our systems are also very different, right? Because if you believe in the mind is spread across the body as opposed to being only located in one location, right? Whereas, have we built anything that is similar in concept? Because as you said earlier, if the webcam is defect and the system is depending on it for the whole AI or whatever to work, it doesn't know now, can I compensate the webcam with my speech synthesis? It doesn't know it. Has it been built like that? But where it comes to the human being, it's one example is people who don't have who have a certain disability, they develop an ability in another aspect, right?
Yes,
Sign
yes,
language. They'll be probably very perceptive. They'll have other creative abilities. It automatically gets developed because the body compensates for it. And it's also same thing with the body. Like, when you notice that if one arm is aching, your other arm takes over in terms of doing, like, taking off the load of the other arm, and goes with the feet as well. And have we built robots that are like that, like not only just self-healing but also compensating for us, like just like the webcam was an example. It's very much centric to and dependent on those, right, senses. Also, if one small part doesn't work, sometimes the whole thing shuts down, right? We
yes,
have that with hardware, right? Like something goes wrong with something, you got to throw it away, you got to buy a new one because it's not repairable, because
yes,
it's affects the whole thing. So we haven't
yes,
built our systems autonomous and decentralized like how we are. And that is also where the intelligence is coming from. In a way, the 6 layers that you mentioned has to do with the decentralization. Like if you look at even the smallest simple gadget you have around you, it's very, very centralized. One component doesn't work, it's kaput, throw it away, got to buy a new one.
yes. I completely agree, because, well, when the very first stages of the neural networks, and it is still happening till today, we have a fixed numbers of inputs and a fixed number of outputs. But when we think about what will happen if I have just white dots, if we are talking on an image, we have just white dots in a part of this image, and we don't have these pixels anymore. We will not consider what will happen with the weights. We are still calculating the weights of this dead. What will happen with the neural networks? And yes, one thing, there is something on neural networks, and which called spike neural networks, and they bring us some ideas of that the natural neuron don't pass some signals if they don't have some triggering. They do the neuron to act need to pass to overcome this trigger. If this not overcome this trigger, the signal will not pass. But in neural networks always have signal, not no matter if a positive signal or a negative sign, always have a signal. And this is showing that we are missing something. Our inputs must be much more adaptive to the changings of the sensors, and adaptive to the what will have what will we have when some sensor will not work, what we have, how to do it with it. When we are dealing, in other hand, when we are dealing uh, with reinforcement learning, maybe this can be overcome. You need to be prepared, build a good architecture of reinforcement learning, but the reinforcement learning tries to understand what to do based on what they received. But our technology right now are still thinking about an fixed input and a fixed output. Never will nothing wrong will happen with our input. Nothing wrong will, but in reality, will happens. In reality, when the reinforcement learning, when we train based on reinforcement, we are expecting that the action will happen and the environment will change. But with the let's suppose we have a robot, and they are able to pick something, some objects. There is a function called pick, and this automatically picks something. They are the learning, they didn't learn how to pick, just learn pick is an action. Well, because when they try to pick you speak as an action, and nothing happens. The environment didn't change because they wanted to pick, and nothing happens. The reinforcement learning will not use that. You will not use that action. This action will be abandoned. Well, nothing happens. The environment didn't change, and and that's the reason reinforcement learning will be increasing. And one of the reasons of reinforcement will be increasingly used, because we can base it our actions on sometimes on a statistical way, base it on what I do in the environment. And neural networks really don't do that. Neural networks, it's don't think in that way.
So
Oh,
I think you got a important point there. I think this is my understanding. There are many different types of intelligences that
yes,
work in a system in a
approach,
very
yes.
complicated tandem way, and they switch and they do tag teaming, do all kinds of swarm intelligence, and sometimes it's only random of them, and we don't know. We haven't modeled that very well. We only model when we think of the neurals, thinking the brain. That's because we are thinking in a polarized area where the intelligence is. When the intelligence is distributed and it's poly-shaped, it's not mono-shaped. Actually, going to that, there's an interesting question from Suash, who's going to segue through something else. What are our thoughts around arts, AI, like AI creating art, music, stories? I think this is a bit of a segue into what you're talking about as well, because that question will require different types of intelligences, or focus on a slightly different intelligence, the creative intelligence.
Yes. Uh, th- the there is a note video from a guy who made a robot able to play piano, and this bot playing piano can play together with him, and while they are playing guitar, the bot is playing piano, and the bot is shaking his head and playing. It's a bot. You as a robot, you can you is not like a human, but is a robot human. And this guy talked at some point of the conversation. They talked. Well, people came to me and asked me, are the robot feeling that emotion? They are glad to be playing. And right now, no, the robot itself are not feeling anything. And when we are making robots or any kind of art, well, art is an expression. Art is a complicated subject, because when it's something different. I am musician, as you can see here. We have a keyboard here. Uh, when we start playing music, one question that as a human I asked myself is my why my dog didn't dance with me. Why the dog didn't understand the pose of tum, tum, why the animals don't start dancing. And this question is so intriguing, because it's they are able, we are when we are talking about evolution, where into what point music became something danceable. There is no middle step. There is no started from human and so on. Didn't don't We don't have a middle step. Or maybe I am wrong, because I am not biologist. I not fully studied the animals itself. But clearly, if this middle stage exists, I don't know. I didn't saw any kind of animal dancing, or a small steps that we can explain how we human understand the beat of a music and feel the emotion of this beat. And this is it. Well, what I can say about that, I don't even know why I'm feeling uh, music is something pretty. I don't know. I didn't. This is interesting point, because we are as human, when we cannot explain taste, we cannot explain. Try to explain the taste of some food. Is not achievable. We cannot put in words. We cannot explain. this is and for us, when we are doing some decisions of in our lives, this is important. Where to go to eat, it's important. It's something, and it's based in something that we cannot explain. We cannot the major things that we are doing in our lives, we cannot explain why we are doing, because we know where things can start. Well, I eat something and I think this something is delicious. That's the reason why I'm going to this place. But I cannot explain why this something is delicious, and cannot even understand why other people don't like that something that you love from the top of your heart. This is a difficult, and when we are doing music, when we are dealing with art, we are touching that unexplainable unexplainable feelings, unexplainable understanding. We are how we can teach something that we can even explain for ourselves what is going on. That's it's a exact a great question. It's an open question. It's a human open question. That idea of my dog didn't dance for me, it's something that I can talk for at least at when I the whole life.
That's a very interesting angle there. So we cannot explain a lot of the different things we do. One of them being taste. Something else would be, why do we like that music? So we are born with certain traits, characteristics, or habits, or likings or dislikings, which we cannot explain. Some we may be able to partially explain, some not explain at all. Then how we may building models? Because I think Suash's question is, if you're going to mix art with AI, what are we actually doing there? Is it
Well,
like just somewhere from the middle? We're probably starting somewhere from the middle and not touching the unexplained areas, but just coming up with some preconceptions, starting from there, and then fusing that idea with the art we already know, and then generating things based on that. So there must be some predetermined points we're starting from, right? It cannot be from the point where we actually start drawing and learning drawing and liking certain things, like, the I don't know if the model can say, okay, actually I like drawing circles, so now I'm going to be Picasso of circles.
yes, yes, great.
Um,
Well, this is I as I understand, continues to be an open question, but there is something that John Searle said. There is an interview with John Searle, and they talk something. I understand that is part of this answer. Well, John Searle said something like that. The experience of feeling feeling happy, that experience is human related, is personally related, but the ability to feel is not relative. The ability to feel is something intrinsic to the hardware. And the idea of John Searle is, well, we need to understand better how the hardware works, to try to mimic, to try to make something closer. And let's think about what we are doing when we are using Wally to make some art. We are not trying to do the same as the hardware do. We are trying to mix images and trying to figure out how this mixing can look for us art. This is a different point of development. The approach is completely different. John Searle will tell you, no, you are in the wrong path, because you are not trying to mimic the how art works. You are trying to you're trying to build art, just making a computer art. But for me, both are clearly okay.
I think I
Because
think I think I learned a concept, heard of this concept long time ago, called the grammar of graphics, which
okay.
can be connected to how we do visuals and visualization. And then that grammar is missing. Like, an artist will know if someone has created this, and what is the idea or message behind this painting. Whereas if you do something that is generated,
Yes.
But
Yes.
then what is the idea behind it?
if I can interject here, there are, Suyash just commented that there are some generative models, etc., that don't necessarily have feelings or even understand art. But I can mention two cases where basically the AI is relying on what people have said or what people have liked. So you can think about those newer systems like DALI. It basically looks at all the art that was done and understands from that what people like or how it's supposed to look like when you ask it to draw something. Another thing is more like the genetic algorithms approach, where it tries different things and it asks you which do you like better, what looks better to you, and then it goes in. The evolution is directed towards what people gave it the positive feedback. So it doesn't really know on its own, but based on feedback
Yeah,
or
it's
based on what.
driven by the subject. Yeah, driven by the subject. I think it's a very good point there. So, but when an artist is doing something like this, um, there is an automatic selection process that's happening for the artist, which they are not conscious about. It's not a mechanical process, because then that defines an artist from an imitator, from a copier, from a genetic GAN art user, right? Because and they all could arrive to similar solutions, but one has
Yeah.
intuitively or out of automatic action achieved that, and sometimes may or may not be able to explain it. Whereas I think, and I cannot speak for these models because I'm not an expert, but they're very good pattern recognizers, right? And good art has a lot of recognizable patterns in it. Okay, if it's abstract art and modern art, I'm not an expert in that subject at all, but there may be patterns in there as well. And because it can do combination permutations, and it'll also use your selection process, like, what you like, what you not like, which art is liked most because of what. It probably has a database of all of that. Now when you give it a lot of art and has got all these categorizations, if it has to start from one art and make it look like another art, it can now blend them together because it knows the grain of the, it may be knowing some grammar of the graphics. It has learned the grammar of the graphics out of giving all these combination permutations of patterns, right? So
There
I
is
mean,
also
you can do that same thing to a child, like Scratch. I think the ones who have children, you give them Scratch, they'll start randomly doing things. Eventually they get a hint of how it works, and they actually start doing good stuff. Same with Lego blocks, right? In the beginning they'll
Yes.
just throw this around and play, and eventually when they get the idea, they'll build some really good stuff, right? So they'll go through a phase of randomization, but then they'll get the pattern, and then they'll start building on top of it. There might be something similar happening with models, but maybe at a much miniature level, or not as sophisticated level as like humans learning to do stuff. But then again, that's my limited view on it.
By the way, I just wanted to add that math and art are related. Patterns and what's pleasing to the eye was in many cases proved to be based on certain mathematical relations. And there is a famous book that's called Escher Gödel Bach about the mathematician, the artist, and the musician, and it discovers relations between these things. And there is a comment from Bradley. I'm going to also put it on the screen. Perhaps I can do it this way. And he said you could make a fortune if you could, from past patterns of great masterpieces, develop an AI that will tell what art will become valuable in the future, like how to invest your money. But I think nowadays it's even harder than ever because you have all these NFTs and a lot of things that don't necessarily that become valuable, not necessarily because of the art meaning of or what's the artistic aspect of them. What do you guys think?
Yes.
So yeah, I think you touched on a very important point. Actually, you brought it up. It's also a subject of interest of mine. You probably cannot see the book here, but if you're interested in learning what's pleasing to the eye, maybe the golden ratio of phi is an interesting topic to discover, because a lot of, not lot, but they have been historically seen that art that follows the phi ratio, like for example, there have been some studies on Leonardo da Vinci's work and other people's work, where they have used the proportions of the the dynamics and the dimensions. In the dimensions of the drawings, they've used the phi ratio. They've maintained it all across, and something like that is pleasing to the eye because of the way nature is embedded with a lot of that, and it feels natural to us, and hence we're drawn to it. Is one of the reasoning, right? Everybody will have a different idea. So if and maybe these models are able to understand those patterns and able to understand those ratios intrinsically, and those ratios automatically get higher weights. So those paintings and drawings in art automatically pop up to the surface, and so then if it understands that, it'll start producing such work automatically, and then they become pleasing to the eye, right? Like the work Valley and Dali and others are doing, they're becoming more and more pleasing to the eye because they are noticing that there's a combination of hues, of colors, shapes, and certain other things at different levels are actually drawing a lot of attention because of certain combination of colors and all those things, shapes, and
Yes,
they're playing
and
around with those patterns.
and there is something important when we are dealing about the learning process, our living learning process, because when we are dealing with thinking about a baby, they have, for example, I will explain use an example. When we are dealing with imitating something, imitating doing something equals to another thing. The first time my professor asked me, well, did you think about trying to do some imitation learning? And I automatically said, well, but to do that we need the concept of self, because when we are imitating something, we need to know we are not something and we are imitating something. For me, it was the first immediately psychological answer. Well, I need to imitate someone. I need to need the comprehension what is me before.
Hmm.
But when I answered that, I I saw in the expression that I am talking about didn't make sense. What this guy's talking about. And so I figure out that there is something related what we are doing right now and something what we have when we are born. For example, when we are born, in this the 5 to 10 minutes, we can, if you show to the baby, if you the baby born with open eyes, if you show your tongue to the baby will imitate you. Will In 5 minutes. There is no time to learn that. And when we ask to biological, medical, or something related to this area, what is going on, they will answer something like that. Is an empathetical answer. It's an automatic answer. They are not imitating you. They are born because this is something that occurs on the history of the Darwin, the history of the species, that imitating at that point increases your potential to be successful. Okay, that in other hand, we have two types of imitation right now. One that is a native imitation, when that you are born with that, and that one, you when you start to understand that you are something separated to the world, you can imitate something because something different from you, because we are two different kind of. I will give you an example of a robot doing that. uh, and that's the two kinds of imitations. Well, what I understand in this, when we are find this kind of mathematical approaches with some evidences that, for example, birds more symmetrical are more able to reproduce than non-symmetrical birds. This is there. That is a research based and concludes that the symmetrics is important. Just like you said, there is some mathematical points that we have born with that, and we understand what beauty is, and we can find some mathematical patterns based on that. But when we start living, for example, if you look at some excessively symmetrical painting, you can feel, well, this is so symmetric. I don't like this because it's overcome my amount of symmetrical. I don't know where this come, but people can think about that. I don't like this, and I don't. And at this point, we are overcoming what we have born, natural born. We are overcoming some kind of. We can understand symmetrical. We can see beauty, but we are not feeling the pleasure of experiencing this image because we learned something in the middle of our lives and we change this natural born feeling. And that's I think what is happening when we are consciousness what we are doing and what we are understanding what we are doing. We can look to ourselves and think and questioning ourselves why you are what why do you what do you feel pleasure looking at that. And this change this beautiful idea that we have some painting changes over our lives. So uh, that mathematical formula we have inside of us changes. I don't know how, and I don't know why it changes while we are living. But at my point of view, the mathematical still there. It's something that you're born, but your learning changes how you are able to accept that the how you are able to accept this is beautiful or not, because you are interfering with, you can overcome the, for example, our pupils are have some, our pupils response to light. When we are so much light increases the size of our pupils, and the at low light our pupils are much closer. But there is some people who train to by will open or close their pupils. In my point of view, the pupils is still there, this mechanism is still working, but we can by learning overcome this natural born feeling. And I believe that in art this can be, because it's happened every time. I was in the when I am studying psychology, yes, there is lots of studies confirming that the idea that symmetrical and mathematical relations have a connection with our body, have a connection what we are like. And yes, this we cannot deny this. We just must accept, yes, there is a lot of the evidence that this is happening.
So
And
yeah, actually, you've been touching on really interesting topics, which are going around the intelligence of our system, the creative intelligence, which I hope someday we'll be able to replicate into another thing, like an object or another robot or machine. But I think we might be a bit way off that, isn't it? And I think I've been enjoying the last 2 hours of this conversation, and we can actually endlessly go on talk about this topic. It's like a highly
yes,
researched
yes,
and discussed topic. So we are heading towards the end of the second hour. So I was thinking maybe take some thoughts from everybody else, Dave, El, myself, Robert. We could just share some sort of closing thoughts, and then we'll have to bring this to a close because, as you know, this is an no never ending topics, but we are limited in time. Uh, so I don't know. I'll go around and I'll start with you, Dave. If you want to have some closing thoughts or ideas or takeaways or anything else you want to throw in
Still
that
on
we might
mute.
have not discussed.
Yeah, I guess the one of the things that this conversation has highlighted for me is just how much. Well, because two things really. One, there's so much interesting stuff happening. There's a lot, there's a lot going on at the moment, both in terms of machine learning and the various interactions between machine learning and AI and other disciplines. Like we talked about arts, we talked about robotics. There's just so much interesting stuff happening, and I think the other interesting thing for me is this. topic of what does it mean? Does the AI have to be aware of what it's doing? Is it still art? Is it still interesting if the AI likes making music or likes making images, or does how much does that matter? Is that just in our heads really, or is that is that an interesting thing we have to worry about?
Yeah, very interesting points, Jack. I mean, sooner or later it'll matter. At the moment, it's fascinating, right? It's beyond our own capabilities, right? But sooner or later, it will start mattering, and that's when we'll have to start solving that problem. Otherwise, you might not be too drawn to it. It'll be a novelty, lasted for a little bit, and no one's interested in it anymore. It's like the calculator, right?
We can't even we don't even know what consciousness is at the moment. That's not been. No one can yet say, okay, this part of the brain is responsible for consciousness, or this system is responsible for consciousness. So it's really hard to say, okay, what actually is the I that's there, and can we know one is present or not? How do we test? Because there's been various news about this so-called sentient AI at Google, where the AI has supposedly said, "Yes, I'm sentient." Well, any chatbot can learn to say that, right? It doesn't
Eliza says that.
Sentient.
Eliza says that in some form. If you run Eliza,
in the movies, see, when they become sentient, they immediately want to survive, even if it kills everybody else. And I wonder if this is really what's going to happen. If that's, I mean, with animals, it's like that. With living things, it's like that because you want to survive and continue to the next generation. You want to reproduce. With the case of AI, I'm not sure if it's going to necessarily feel the same or cause the same, unless it's learning it from us.
Yeah. I mean, there's one of my things. I read a lot of science fiction and fantasy, and there's been a couple of interesting stories around the interplay between AI and emotions. In this, you could have something that's smart, but if it doesn't actually feel it, and it has no will to survive, then maybe it doesn't care.
Yeah, actually, it's interesting you bring that up. I'm reading this book, Emotional Intelligence, by Daniel Goleman. I don't know. It's a fairly old book, and actually IQ is not given so much of an importance in his book. He feels that EQ is a better, and it's the one that's helping us survive, because he's made these studies where people with IQ will make these steps and these actions and these decisions, but the people with EQ is because when you are pressed for time or in a crisis, it's your EQ that kicks in, not your IQ. And so now, actually, if we had to go back to the conversation Hobbert was having earlier, and yourself as well, Dave, are we actually building the EQ? Is there a model that has got EQ data in it? It's all IQ, right? A lot of it's IQ. If you argue, it's a lot of it's IQ. Almost all of it is IQ. I don't know if there's an emotional database somewhere where you've mapped it into a neural network or using reinforcement learning, learned emotions, right? And it has to blend in with IQ, but there's no IQ in the database at the moment. EQ in the database, it's all IQ, in my view, because it's all knowledge that we are capturing from Wikipedia databases and whatever Google is getting from, and all of that is IQ, and somewhere there's hidden EQ, but it's probably just very, very tiny bits.
Yes, the research. Yes, the point of view of emotions when we are looking for research is much more in detecting emotion than feeling. It's much more, well, I can detect this emotion in this text, I can detect the expressions of the face, but feeling itself, it's a open question.
Yeah, I mean, feeling itself, you need to have emotions to feel emotions, right?
Yes,
I don't know
yes.
if I'm right to say that, but it is an IQ ability to detect emotions for a computer, right? It'll look at the size, the metrics, the volume. I don't know. We've got all these metrics that we measure. Okay, in a sentence, if you write negative words, then okay, it's a negative sentence, right? So that's the negative emotion in the sentence. Sorry, Dave, you're going to say something before I was.
Yeah, I was going to say that. The whole question of what an emotion is kind of an interesting point. I mean, again, I think I mentioned her before, but Lisa Feldman Barrett, she has quite interesting work. She maintains that there aren't these built-in emotions. These are things we've learned. We've learned, oh, this strange feeling in my body, that means I'm angry, or this strange feeling in my body, that means I'm nervous. But the whole literature around recognizing emotions makes these assumptions. Oh, there are these 6 universal emotions, and some of that research that led to that has been since discredited. So it's not entirely clear how much actually is universal and how much is kind of cultural specific or is learned.
Yes, you touched on a point I was about to talk, because well, we have a sense of ourselves. Well, let me try to explain my point of view, personal point of view, what consciousness can be or something related. And as I understand, our intelligence and our awareness is something plastic, able to be in any kind of living being. We can't. This is an ability, and we learn about ourselves. And I have an example of doing that, because when I was making an bot, I was making a bot playing Doom, the first person game, and I am making some detecting person, a class using deep neural network, and my hand was with the gun here, and they are detecting my hand in shooting. Oh man, it's my own hand. Don't shoot. There's nothing to there's nothing. There is no enemy to kill. It's my own hand. So I when I when I started to understand that, it's like the same psychologists are telling in the development of the children. There is a place where the children understand that he is the place itself. There is no differentiate. There is no they w- the place, the world, and the universe and the children are a whole. We are not separated. But when we are getting old, we are understanding. Well, this is me. This is other person, and in another step, we understand that other persons are not physical. Only physical other persons are thinking other persons with different tastes. So I understand that at that time, looking at playing Doom, when I'm self-detecting, well, I need to learn what is me playing this game. It's important. Because I need to understand that detection is a person, right? Is the hand, but it's my hand. It's not the other hand. And I figure out, well, this is being so much psychological than I was expecting, because I need to understand what am I. And the robot, and this will happen with the robot, because if we put some camera over the robot at sometimes will see their hand in the screen. The robot was moving, and at some point, wow, this is my own hand, and I need to know this is my hand, and I need to exclude this hand from the what I am processing in that image. And for me it was mind blowing. Well, we are much more in the direction of the psychologist than I was expecting. We need to make the robot understand themselves, and understand what others means, and what is, and recognizing people, and recognizing what people do something. And as you talked at the chatbot at the beginning, yes, we need to memorize what is going on. We cannot forget. Put the camera outside and go back. We need to know that is the same place that I was looking before, and this is me. This is the place. This kind of connection is learned, and I was not expecting that I need to teach the robot that the robot itself, that is me, that isn't me.
Yeah.
It's part of this it's part of this epoch that we are living right now. We are increasing the philosophical question about our artificial intelligence, because the techniques are evolving, and we are touching highest grounds, we are
Mm.
touching highest levels. The conversation is increasing.
Yeah.
We are touching much more closer philosophical questions that are far away some years
Mm.
ago.
Yeah,
That is
absolutely.
one of.
Yeah, absolutely. So, Eyal, I think both Dave and Hobbert and Robert, to call him rightly, have actually converged this conversation to the interesting point, which is an even more discussed topic about consciousness and I, and trying to bring that into the world of automation, robotics, artificial intelligence, and the works. Do you want to add something to it as a closing point? Because I've already blended my conversations with both of theirs, but I think I haven't heard much from you as a good segue and a closing and wrapping up, because we can endlessly go into this
Right.
this consciousness conversation, which is like a sort of a rabbit hole. But I'll pass that over to you so we can make a good closing.
So all I can say is my interest in evolutionary computation, genetic algorithms, where intelligence sort of is built by evolutionary methods, and you can do things without actually. You can do a lot without um, self-consciousness and with or self-awareness, and also even without previous knowledge. Even though it can help, but you can learn things from scratch, but it just take longer. Um, I so I think that don't know too much, and I don't have too much experience in when it comes to beyond that, to self-awareness or sophisticated psychological models. So I really was fascinated by this conversation, and I learned a lot, and I probably still have a lot to learn. And that was great. It's just a shame that our time is limited, and some of us have to go to sleep, some of us have to just keep going. And I wouldn't mind continuing this at some point.
Yeah, we could have another second session uh, with topics that we haven't covered in this, and move from, and take off from that session. But the good thing is, this all of this is recorded for the benefit of those who want to hear it again, who couldn't be on this session. And I think your video is going to be on YouTube. Is that right, El?
Yes, in a
Yeah,
couple of days it should be on YouTube. I'll let you
perfect.
guys know.
Sounds good. Cool. All right. I'll leave the closing to you, El, because you are the host and the the creator of this event.
Okay, that was great. I had a lot of fun. Thank you, everybody. Thank you, Robert. Thank you, Dave, and thank you, Manny. And hope to see you again soon enough. Good night, everybody.
Thank you. Good
Good night.
night. Bye bye. It was great to be here.
Likewise.